This video is going to be a continuation in our functions review unit, only this video is going to solely focus on rational functions and asymptotes. So we'll start off with a definition. Rational functions are a function that is in a ratio of two polynomials. It is rational because one is divided by the other, just like a ratio. And if you look off to the right here, this is what your rational functions should always look like. One thing we want to make sure we know, an asymptote is sort of like a boundary line, so that's going to help when we have to sketch. We need to find asymptotes. There's two things we can look at. One is a vertical and one is a horizontal. We'll work through the left-hand side and then move our way to the right. When you need to write the equation of a vertical line, that's always going to be that x equals a number. And the vertical asymptote will occur from negative infinity to positive infinity. If you want to determine vertical asymptotes, in other words, you want to see what the behavior of the graph looks like, you're looking at the graph that looks like this. And if you look and you want to highlight, that's your vertical asymptote. So it's kind of like the wall to the left or to the right of how far the function could go. If you want to, and I would start this part, it's your steps, determine the vertical asymptote. It's where you want to find the denominator equal to 0. So you set the denominator equal to 0 and you solve it. For instance, here's a rational function, it's in a fraction. I would want to set x minus 4 equal to 0, and x equals 4 could be my vertical asymptote. Now the reason that I say could be is put a little note here. You always have to check for a hole in the graph. We're not going to do that here because on the second page we actually review the steps on how to check for a hole. But I do want you to make a note that once you find that vertical asymptote, you have to check that it's actually an asymptote and not just a hole in your graph. So if you look on the right-hand side, here are steps for determining horizontal asymptotes. This is always y is equal to a number for the equation of the line. Horizontal asymptote is one that looks horizontally. So it's going to be something that looks like that and bounds the graphs from going up and down. There are three cases that you have to consider in order to figure out the horizontal asymptote. Case one is where the higher degree is in the denominator. If the higher degree, and degree is the exponent, the higher power, is in the denominator, then the equation for the horizontal asymptote is y equals 0. If, in the case that the function has a higher degree in the numerator, so the higher exponent in the numerator, that means that there is no horizontal asymptote. And the last case that we have to consider is if the degrees of both of them are the same, so if they're matching, then the horizontal asymptote exists at y is equal to a over d, where a is the coefficient on top and d is the one on the bottom, so you just take their coefficients and make them a fraction. So for instance, if we notice the higher power for the first example is on top, that tells me that there's no horizontal asymptote. How did I know that? Because the higher degree was on top. Okay, next example. If I look for the higher degree, I see that it's in the denominator. That tells me that y equals 0 is the equation of the horizontal asymptote. All right, and if you flip your page, we can continue with one more example. If I'm looking at the higher degree, I actually see that the degrees match, top and bottom. So you just take those coefficients of the matching and I get 2/5. All right, and like I said on the first page, here's the special case. When you're checking for a vertical asymptote, once you get an answer, you want to actually check to see if there's a hole instead of a vertical asymptote. This is what the hole looks like in a graph. It's just like a little break where the graph stops and then restarts again. And the way that you want to do that is you're going to check at f equals 2. Why 2? Because when the denominator was set equal to 0, you got x equals 2. And so we think there's a vertical asymptote, but if I check f equals 2, we get 2 squared times 2 minus 2 over 2 minus 2, which results in 0 over 0. This is the instance that tells me that there's a hole in the graph. So there's a horizontal, oh, I'm sorry, I would say that there's no asymptote at x equals 2. It was just a hole. All right, moving on. We'll do one example together. You'll do that example on your own, following the same sort of steps. So starting with vertical asymptotes, what we just said, vertical asymptotes are take the denominator, set it equal to 0. You would get x is equal to negative 2/3. So at x is equal to negative 2/3, we have a horizontal asymptote. For a horizontal asymptote, I'm looking for my rules. I see that the powers match. I see that x to the 1 and x to the 1. So, oops, I'm sorry. I would say that y is equal to just the coefficients, so it's 1/3. We have the y-intercept, you would need to show this procedurally. So I do want to point out, I know a lot of you can find this in your calculator, both the x and the y you would need to show. So for y-intercept, that's when you're plugging in x equals 0. So we have 0 minus 2 over 3 times 0 plus 2. And this will result in negative 1. So that means the y-intercept is negative 1. For your x-intercept, that's when the whole function is equal to 0. So I have 0 is equal to x minus 2 over 3x plus 2. When you cross multiply and you solve, this will result in x equals 2. Now, your domain is all of your values for x, so left and right, and in this case, rational functions, x can be all real numbers with the exception of that asymptote, so all real numbers, but x is not going to be equal to negative 2/3, and I have to check for holes. Now, checking for holes has to do with our vertical asymptote value, so I need to check at f equals negative 2/3. So I have 2/3 over 2, because that's my numerator. I already know, excuse me, 2/3 times 2. I already know my denominator equals 0 at that point, so if I go ahead and check it, you'll get 4/3, which is not equal to 0, so we can say that there is no hole. Now off to the right-hand side, it's asking for us to sketch. In this video, I'll tell you all of the required components of a sketch to get all credit, starting with your axes. Then go down the line, vertical asymptote at negative 2/3. And let's label it, that's x equals negative 2/3. Everything you graph is everything you label. Then we have y is 1/3. And again, it's a sketch, so as long as I'm labeling and it's in approximately the right location, we're good. Y is 1/3. Then if we go through, I want to graph my y-intercept. My y-intercept is at negative 1. And we do have to label that, so it's negative 1, 0. Then I have an x-intercept at 2, 0. And then I can go through and I can connect those, and you know that your graph will be bounded by your asymptotes, so it'll get super close but not actually touch them, and it's going to go those 2 points, and rationals are opposites of each other. So that's the rest, and I'll call that f of x. And checking that I have all my details, all my labels, that's what a complete rational function question will look like. So now stop the video, replay it if you need to, and try the your turn question, and of course, make sure you check both keys.